Hi everyone, welcome back to Basic Networking course. In the last session we have discussed about the introduction to basic networking, and as a part 2 or the session 2 we are going to discuss about the most important part of networking, that is OSI layers. OSI layers or open system interconnection layers. The OSI layer explains the complete communication between the different systems, that is how the systems interact with each other. So the OSI layer architecture is designed by two organizations, mainly ISO and ITUT. ISO is International Standard Organization and ITUT is International Telecommunication Union Telecom Standard Sector. OSI layer is a layered architecture. Why we should go for a layered architecture? The main necessity or need for a layered architecture is that it simplifies the network design, and further if you have a layered architecture it is very easy to debug the network applications, and moreover the network management will be quite easy if we have a layered architecture. And in each layer, as we said, in OSI layer we have 7 layers. In each of the 7 layers we are using some certain protocols. A protocol is nothing but a set of rules, and a set of rules defines how the data is being exchanged, how the control and the timing for the handshake between layers happen in the case of each layers. The open system interconnection model. There is a history behind this open system interconnection model or OSI model. The ISO or International Standard Organization established a committee in 1977, and the main aim of this committee is to develop an architecture for computer communication, and the OSI or open system interconnection reference model is a result of this effort. And in 1984 this open system interconnection reference model was approved as an international standard for communications architecture. And the term open denotes the ability of the computers, that is ability to connect any two systems which conform to the reference model and the associated standards. Going for the OSI reference model, the OSI model is considered the primary architectural model for intercommuter communications. The OSI model describes how the information or data takes its way from application, like for example applications like spreadsheet, through a medium like a wire to another application program located in another computer network. That is, it simply describes how the data is being transferred from one computer to another computer. The OSI model solves the problem of moving the information from one computer to another computer, that is, it is being passed, the information is being passed through 7 layers, and that is rather than simply transferring a data from one computer to another computer, this particular thing is being divided into 7 layers, or it is divided into 7 manageable problems. It is called as layering, and hence the OSI reference model divides the problem of moving the information between the computers over a network medium into 7 smaller and more manageable problems. The separation into smaller, more manageable functions is known as layering. And the OSI reference model consists of 7 layers: the physical layer, data link layer, network layer, transport layer, session layer, presentation layer and application layer. Each one of them is explained. Going with the first layer, that is physical layer. Physical layer, as the name suggests, it gives or provides a physical interface for the transmission of the information. So the main function of physical layer is that it defines rules by which bits are being transferred from one system to another through communication medium, and it covers all the mechanical, electrical, functional and procedural aspects for physical communication. Such characteristics involve voltage levels, timing of voltage changes, physical data rates, maximum transmission distances, etc. Going for the second layer is data link layer. Data link layer attempts to provide a reliable communication over the physical layer interface. So what happens in data link layer is that it breaks the data frames and reassemble the receive frames. That is, each bit of information is divided into different frames and they are received on the receiver side. After receiving it, they are being reassembled. And in the data link layer, you can create and detect the frame boundaries, and it gives another option to handle errors by implementing acknowledgement and retransmission schemes. It also implements flow control, and this particular data link layer supports point-to-point and broadcast communication. So what do you mean by point-to-point communication? Point-to-point communication means we can communicate, that is two systems communicate. We can send the data from one system to another system, that is point-to-point communication. At the same time, broadcast communication means we can send the data or information from one particular system to all the other systems in the network, that is broadcast communication. And it also supports simplex, half duplex and full duplex communication. So going for the third layer, that is network layer, it implements the routing of the frames through the network, that is how the packets are being sent through the network is handled by this network layer. The main functions of the network layer are, it provides the optimum path, or it finds out the optimum path for the packet to go from the source to the destination, and it also defines a logical addressing at any point can be defined, and it also handles congestion in the network, that is while the packets are being sent through the network and there are chances for traffic congestion. These things are handled by the network layer, and also it facilitates the interconnection between heterogeneous network, that is it provides internetworking. And the network layer also divides the fragment or the packets into different fragments, that is to smaller packets, so that to accommodate it into different media. So in the case of a network layer, we have already discussed about the functions of network layer, and there are protocols for network layer. There are two types of protocols, routing protocols and routed protocols. In the case of routing protocols, it finds all the possible paths and chooses the best path, that is routing protocols. In the case of routing protocols, we have RIP, IGRP, EIGRP and OSPF. And in the case of routed protocols are the protocols which carries the data in a particular chosen path. And for that we have IP, IPX and AppleTalk. Going for the fourth layer is the heart of the OSI layers, that is the transport layer. The main purpose of this layer is to provide a reliable mechanism for the exchange of data between two processes in different computers. So the main functions of this transport layer are, it ensures that the data units are delivered error-free and all the data units are delivered in a sequence, and it also ensures that there is no loss or duplication of data units, and it also provides two types of services, that is connectionless service and connection oriented service. And in the case of a transport layer, that is the heart of the OSI layer, it uses mainly two types of protocols. One is TCP and the other one is UDP. TCP is transmission control protocol and UDP is user datagram protocol. Going for the fifth layer, that is the session layer. The session layer provides mechanism for controlling the dialogue between two end systems. That is, it defines how to start, control and end the conversation between the applications. And as in all layers, it also has the functions and protocols. And the main function of a session layer are, it establishes, maintains and terminates different sessions. And also it provides services like dialogues between full duplex or half duplex communications. And further, it also provides some checkpointing mechanism. A checkpointing mechanism is nothing but if any failure occur in between the checkpoints, all the data will be retransmitted from the last checkpoint. That is called as, or that is known as the checkpointing mechanism. So these are the main functions of a session layer. And as in all the other layers, it also has two protocols. One is network file system NFS and the other one is remote procedure call or RPC. Going for the sixth layer, that is presentation layer. The presentation layer defines the format in which the data is being exchanged between two communication entities. The main functions of a presentation layer is that it converts the data from standard format to machine format, and also it handles the compression and decompression of the data as well as encryption and decryption of the data. That is, it helps in the compression and decompression, and also it provides functions like cryptography. And the main protocols which are used in this presentation layer are ASCII, GIF, TIFF, JPEG, AVI and WAV. Going for the seventh layer and the topmost layer of the OSI model, that is application layer. The application layer interacts with all the application programs and is the highest level of the OSI model. The main functions of the application layer are, first thing, it provides a user interface and also gives network services to the user, and the identification of the port number depends upon the services that we are using. And the protocols of the application layer are DNS, DHCP, HTTP, FTP, SMTP, Telnet, etc. For some examples of application layer are, file transfer, electronic mail, remote login, etc. Till now we have discussed about the 7 layers of the OSI model, that is the 7 layers, the protocols and the functions of the OSI model. Now let's see what happens in action, in practical sense, what happens in an OSI model. First, a message begins from the topmost layer, that is the application layer. The message starts moving down through all the different layers to the physical layer. So as the message descends, each successive OSI model adds a header to it, and this header which is added to the message will describe what that particular thing, what that particular layer should do to that particular message, and finally it will reach the physical layer. And at the receiving side, that is at each layer, the headers are being stripped from the message and it travels up the corresponding layers. So that is how an OSI layer works. We have come to the end of the session 2. I hope you all understood about OSI layers, the protocols and functions, and how an OSI layer works. So in the next session, let's continue with Ethernet, Wi-Fi and Bluetooth. Thank you.